Welcome aboard the Bio Train. In this video we're going to take it straight from the notebook with basic chemistry and the structure of an atom. When studying life, biologists often look at different levels of organization. The lowest level of organization usually looked at in biology is the atom. Everything in the universe that has mass is made of atoms, including living organisms and living cells. Out of all the elements in the periodic table, living things are made up of mostly 6 main elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. In this video, we're going to focus on the basic structure of an atom. Atoms are made of 3 main particles: protons, neutrons, and electrons. Protons and neutrons make up the dense nucleus of an atom. Protons have a positive charge, while neutrons are neutrally charged. Both protons and neutrons have the same mass, 1 atomic mass unit. The protons and neutrons make up all of the significant mass of the atom in the dense nucleus of the atom. The third type of particle that makes up an atom are the electrons. The electrons are found in the area outside of the nucleus. They have a negative charge, and they also have insignificant mass. The periodic table of elements contains information to allow us to figure out how many protons, neutrons, and electrons are found in each type of element. The periodic table always contains the following information for every element: the atomic number, the element symbol, and the atomic mass. Sometimes a periodic table will also list the element name underneath the element symbol. In this example, we are using the element carbon. Every element has a different atomic number. The atomic number is equal to the number of protons that an atom has in its nucleus. Carbon has an atomic number of 6, which means it has 6 protons in its nucleus. The atomic mass of an atom is the combined mass of all of the protons and neutrons of an atom. You may notice that the atomic mass is not a whole number. This is because not all carbon atoms have the same number of neutrons. Every carbon atom has 6 protons, but there are some carbon atoms that have slightly different numbers of neutrons. So the atomic mass is an average of all of these different types of carbon. At this level of basic chemistry, we are always going to round off the atomic mass to the nearest whole number. So in the case of carbon, 12.011 would be rounded off to 12. After you've rounded off the atomic mass, you can use the mass number to figure out the number of neutrons. You subtract the atomic number from the atomic mass to find the number of neutrons. For example, to find the number of neutrons in a carbon atom, you would subtract the atomic number 6 from the rounded off atomic mass 12, and you would find that a carbon atom has 6 neutrons. The last thing we can do is figure out the number of electrons that an atom has. The number of protons is equal to the number of electrons. Atoms are neutral, so the number of positively charged protons is equal to the number of negatively charged electrons. To recap, everything in the universe that has mass is made of atoms, so living cells and living things are made of atoms. Atoms are made up of 3 main particles: protons, neutrons, and electrons. The protons and neutrons are found in the dense nucleus of the atom. Protons have a positive charge, while neutrons are neutral. Both protons and neutrons have a mass of 1 atomic mass unit. Electrons are found in the area surrounding the dense nucleus, are negatively charged, and have insignificant mass. The periodic table gives you all the information you need to calculate the number of protons, neutrons, and electrons that an atom has. You should memorize the following rules. The atomic number equals the number of protons. The atomic mass is equal to the number of protons plus the number of neutrons. To find the number of neutrons, you subtract the atomic number from the rounded off atomic mass. And finally, the number of protons is equal to the number of electrons. That was a basic introduction to the structure of an atom and also how the periodic table contains information so that you can calculate the number of protons, neutrons, and electrons that an atom has. I hope that helps you stay comfortably seated on the biotrain.